Hello everyone, this is my first video in which I would like to introduce some basic concept of descriptive statistics for numerical variables in R. First of all, we need to load some data into our environment, and in this case I load a dataset which is already built in R. This dataset is called Iris. It's always good to understand what we are using as a dataset. If we type $Iris, we will see that the content of this dataset is basically specifying the sepal length and width and petal length and width for 3 different species of iris. For 50 flowers, so we are expecting to have 150 observation. It's iris dataset. How do we know there is a data frame? One of the functions that we have on R, it's called class, which returns the type of object we are talking about. Of course, being R an object-oriented type of programming, it's important to know what we are having as an object in our environment. And if we type class iris, we can clearly see this is a data frame. But then we might not want to know how big it is and how it's structured. With the typing dim iris, we basically having some measurement of the dimension of iris. We have 150 observation and 5 columns which are representing our variables of interest. But if we want to have a more in-depth idea of the structure of iris, we should type str iris, and in this case we can clearly see much more information derived from this command. First of all, again, we know that is a data frame. We know that there are 150 observation of 5 variables. And here we have the name of the variables, and you can clearly see at the beginning of each variable a $sign. This is the way that R use to identify each specific variables from a data frame. So when you type the name of the data frame, in this case will be iris, followed by the $sign and the name of the variable, you are basically identify the specific variable you are using. We have here 5 variables: sepal length, sepal width, petal length, petal width, and species. There are 4 numerical variable and 1 factor variable with 3 levels. First of all, it's easier to have a look at the dataset like you will always have in a normal spreadsheet, and this is how it looks like. So the first column is simply identifying which observation you are considering. In this case, with the head command, it's showing you the top 6 observation of the database. And then we have these 5 variables as we already discussed: sepal length, width, petal width, and the species, with the first few values for each observation. As you can see, this reflects exactly what we have seen earlier in the structure of the database. If we want to know the name of the specific variable, sometimes this is useful when you have hundreds of variables, and you can click names followed by iris, and this will show you the name of the variables in a list. So now we know that we're talking about a database and we want to focus on a numerical variable. To focus on these numerical variables, we have to identify one of those. So a numerical variable, it's a variable that has a meaning of numerical measurement. For instance, length, for instance height, for instance weight. Those are numerical variables. So in iris, the first variable, the first 4 we already know by the previous commands, but the very first one is called iris, is called sepal length, and if we click class, we clearly see that this is a numerical variable. And let's have a look at it. So here we have the full variable reported as a single vector. It's a numerical variable with a wide range of numbers across throughout 150 observation. We already know that from the previous analysis. So the first things we want to do in describing a numerical variable is to calculate a measure of central tendency. This could be clearly used with the mean. Mean is very commonly used in a measure of central tendency, and is very useful especially when the variable is normally distributed. So if we click mean and then in bracket iris sepal length, so my variable of interest, remember the $sign between the database and the variable name, we obtain the mean of this variable, and in this case is 5.843333. Mean can provide you with other option, for instance the option trim. If we want to remove a fraction of our observation from the very end of both sides of our distribution, we can use trim. Trim goes from 0 to 0.2, from 0 to 0.5. In this case we decided to use 0.2, and the mean in this case is 5.797778. We see is different because we have been trimming the 0.2 edges of our distribution. So what happen at mean if we have missing values? To do this I had to create a new variables. As we can clearly see, our variable hasn't got missing values, so I've created a new variable. We will go through this this way of creating new variables in another video. So I created these new variables in which I have replaced every value which was 5.1 with an NA. We can clearly see the first value was 5.1 and it's been replaced for an A. The 45th value was 5.1 and again is an A. So now we have missing values across the variable. If we run min, we can clearly see that it does not report a number, but it gives you an A. And this is because simply the function cannot calculate a mean, as some of the observations are meaningless for a numerical variable. Therefore, cannot provide you with an accurate mean. So there is a way to avoid this, especially when you have a large amount of missing values. First of all, it is never good to run an analysis when you have a large amount of missing values, and in theory you should use imputation, but at times you can use it by removing the NAs, so the missing values, from your variable. This can be easily done with min by simply introducing this na.rm equal true, meaning removing the NAs from my variable, and we can now see that we obtain a value 5.89078. And it's important to understand that this is very different from the previous mean. Of course, the larger number of missing values, the more different this will be from the real mean. What if we want instead calculating the median? The median is another measure of central tendency. It's a value that separates the higher half of your distribution from the lower half. Median, again, is very easy. In R, you just simply type median and your variable in bracket, and you'll have the median, which in this case is 5.8. Median is also can be calculated when you have missing value. Again, you will face the same problem. We have NA reported, but if we introduce NA-RM true, you definitely have a value which was 5.8. So finally, mode. There is no built-in function for mode in R. In fact, if you type mode using this command, you simply receive the outcome is simply the type of storage that the object has. So, but we can load a different package. In this case, I use this package, which I found very useful. It's called desk tools. To call a different package, you have to use the command library. This will load this package. into your environment, and you can use mode. Be careful here, because mode here has a capital M. R is very sensible to capital letters, so if you use the mode with this type of writing, won't come out with the right command. So you have to remember that mode here has a capital M, and when you type mode you have 5. Is this the mode? The mode is simply the most represented value into your distribution, and if we table our iris distribution, we can see that 5 has been represented 10 times, while the rest of the values have been represented less frequently. You can clearly see that the mode is actually 5. The descriptive statistic, this is only a very basic introduction to them, but there are many multiple different functions that we can use to describe a numerical variable in R. One of the most common is, for instance, summary. If you run a summary for a numerical variable, you can obtain again mean, median, and as well as mean and maximum, as well as in a first quartile and the third quartile. A very clear explanation of the distribution of this numerical variable. And if we want to go even further, we load the package psic and we launch describe, which is a common function of this package, and here we have even more information. Again, we have mean, median, and standard deviation. We will go through standard deviation in the next videos, as well as mean, max, and kurtosis, range, and skew. All this will be explained in the next video. Thank you for following this video, and I hope to see you soon in the next video, in which I will talk a little bit more in depth about descriptive statistics. Thank you.